Hello, dear students. Today we're having our last section in chapter 9, which is the calculus of polar coordinates. So as you notice, we started with, we had the same pattern. We were dealing with parametric equations, and then we covered the calculus of parametric equations. Same with polar coordinates. We covered the polar coordinates. Now we need just to cover the calculus of the polar coordinate. This is like a simple short section. Basically, what's required from you in this section is just only the first derivative. I need you just only to know the first derivative. So what we need to do, remember, in general, when we deal with the polar coordinates, how did we define x and y? You need to know these two basic equations. So we said that x is equals to r cosine of theta. Remember, always the cosine is connected to x. Y equals r sine of theta. If I need to find the derivative, remember r could be like a function of theta. R is a function of theta. Now, if I need to find the first derivative, it's like exactly the same rule as we did with the parametric equations. So dy over dx equals dy over d theta divided by dx over d theta. Exactly the same thing, okay? So how can we apply it? We need to be careful about one thing. Now y is equals to r sine of theta. If I need to find its derivative, remember that r is a function of theta, okay? It will be given in the question. R is a function of theta. So if I need to find the derivative, I need to deal with this as a product rule. This is like u times v. So you need to do it as u prime v, okay? So you see just we did u prime v plus u v prime. So you need to be careful that this is the product rule. Same thing for x. F of x cosine, I'll use it as u times v. So what dy over d theta, I use this rule, the derivative. Same for dx over d theta. As long as the denominator can't be equals to 0. And we'll do one question only for this section. It's like straightforward question. So what you need to do here in this problem, we need just to define what's x and what's y, and we find their derivative. So basically what I'll be doing here, just I'll say that x is equal to what? R cosine of theta. And this is equals to, notice that r will be given. So x is equals to r, which is sine 3 theta cosine theta. This is x. I need to do y also. Y equals r sine of theta. And this is equals r, again, it's sine 3 theta sine of theta. Now to find the derivative, okay, to find the derivative, I need to find dx over d theta, dy over d theta. Let's prepare them. So dx over d theta equals to, this is like the product rule again. So this is equals derivative of the first, this is a 3, don't forget chain rule, cosine 3 theta, cosine of theta, and then plus, I leave the first and find the derivative of the second. So this is, we need negative sign. So this is minus sine 3 theta sine theta. Now I need to find dy over dx. Oh, dy over d theta, sorry. dy over d theta, same thing. First derivative, this is equals 3 cosine 3 theta sine theta. And derivative, we leave the first derivative of the second. This is plus sine 3 theta cosine theta. Now we'll find the derivative. Dy over dx equals dy over d theta divided by dx over d theta. And this is equals to, remember y, the derivative of y over x. So this is a 3 cosine 3 theta sine of theta plus sine 3 theta cosine of theta divided by 3 cosine 3 theta cosine theta minus sine 3 theta sine of theta. Notice that here they need the derivative at theta equals pi over 4. So dy over dx at t equals pi over theta equals pi over 4. So try to replace the values. It would be equals to 1 over 4, 1 over 2. And remember, the first derivative, you can just say that this is the slope of the tangent, okay? One of the application, this is the slope, and it's equals to half. We could ask for the tangent equation. Again, you have the point, you can find xy, same as we did with the parametric equations. So anything related to the first derivative is required in this section, okay? So that's it, 9.5, easy and simple, short section. And by this, we end chapter 9.